All right, so chapter 2, we see I'm gonna cover section 2.1 functions. Okay, I know some of you already know about functions, but so we need the chapter 2, all throughout chapter 2, we're gonna focus on studying functions. Okay, so first one, objective. Let's see, sharing. So 2.1. Okay, so functions. So objective is this. Yeah, definitely we're gonna study definition of functions, right? So definition of functions. And second objective, yeah, so we're gonna study how to identify functions, okay, given equation or given set of ordered pairs or given graph, we want to identify whether or not they are functions, okay? So okay, so now the one of the way to identify whether or not given equation or something given information is functions, we use is that a vertical line test. Okay, so the vertical line test. All right, and then yeah, we're gonna study range and domain and range. So we're gonna study how to find the domain and range. Okay, and range. Okay, then next one we're gonna study yeah. So here in this section there are too many objective, right? So it means that this section is kind of important. Okay, so function was you're gonna study the function notation. Okay, so this objective is quite important because later on, I mean, after section 2.1, I mean, once we learn the function notations, we're gonna use the function notation a lot. Okay, so if you miss this class or this section, studying these sections, then you're gonna get a lot of trouble. Okay, so because from the section 2.2, every single pages, on the concept, we're gonna use function notation. So if you fully don't understand this one, function notations, then you're gonna get big trouble. So last one is the difference quotient. This is formula, okay? Okay. So let's start from the definition of function. So see, yeah, right there. Okay, so we move to next page. Okay, what is a function? So before the look uh, seeing the definition of function, let's take a look at the concept of functions. Okay, so if the value of a variable y is determined by the value of another variable, okay, so on the variable x, then y is a function of x. So simply saying that function, I mean, y is a function of x means that the variable y is determined by the another variable x. Okay, but so yeah, so the praise is a function of means is determined by. But what if there is more than one value for y corresponding to a particular x value? then y is not determined by x, and y is not a function of x. Okay, so let me give you an example for this one. Okay, so here, so we learned the the linear function, right? So that is the linear equation with two variable, right? So let me give you an example in that linear function. Okay, so example, so think about this: 2x plus 3y is equal to 1. Okay, so we know that this is the linear function. Why? Because this is the has the what, the standard form, right, of the linear function, right? So but let me isolate y, okay, to figure out the slope. Okay, so converting this one to the slope intercept form means that I'm going to isolate y. Then we got this: y is equal to negative 2 over 3 x, right? And then plus 1/3, right? All right, so now as you can see that whenever we plug in real number into x, then y value is determined, right? Okay, so for example, when x is what when x is negative 2, when x is negative 1 and 0 and 1 and 2. Okay, so we can plug in any real number into x. Okay, then let's find the y value corresponding to x value negative 2, negative 1, 0, 1, and 2. Okay, so when x is negative 2, y value going to be what? 5 over 3, right? When x is a negative 1, y value going to be what? 1, right? Okay, so when x is 0, we're going to get 1/3. Okay, and then 1, what? 1 negative 1/3, right? Need more space. Okay, so when x is 2, we're going to get negative 1, right? Okay, anyway, so as you can see that the y value, variable y, variable y is determined by the variable x, right? We can say that. So now we can say that this is y is function of x. Okay, and then or we can say y is determined by x. Okay, so and then you see that here, all the pairs, the set of all the pairs actually see that here, the set of all the pairs right there. So we see a collection of, collection. Okay, set of all of the x coordinate. You know, the in order pair, the first number is called the x coordinate or first coordinate, right? So the set of all of the first coordinate is called the domain. And then the set of all of the y coordinates is called the range. Okay, so we see how to find the objective, how to find domain range. Now you got the domain range, but yeah, we'll see the definition of domain range a couple of slides later. But okay, just keep in mind this domain is what? The set of all of the x coordinates. The range is the set of all of the y coordinates. Okay, but so yeah, and then let's see the other examples. Count example actually. The what kind of equation uh, is not a function? Example of non-function. So equation circle: x squared plus y squared equals 1. So every single circle, equation circle, is not a function. It means that y is not determined by x. Let's see why. Because you see, think about this. When x is let's see, when x equals 0, okay, think about let's try to find out the variable y corresponding to the variable x 0. Okay, let's see. So then the if what x squared plus y squared must be 1, right? Must be 1. So when x equals 0, y must be 1, right? Because 1 squared is 1. But at the same time, when x equals 0, y can be negative 1 because negative 1 squared is 1. So 0, 1 and 0, -1, these two, order pair must be on the graph of the circle of that equation, right? So you see the what? For one x value, there are two distinct y value corresponding, right? So in this case, y is not determined by x. Okay, so this is not the example of function, actually counter example. Okay, so we're gonna see this example again, but just keep in mind this. Okay, so back to the slide right here. Okay, so now next slide, function concept. Okay, so when discussing two related variables, we can identify one as the first variable and the other as the second variable. Yeah, we already know that in order to pair, just x coordinate, y coordinate, or first coordinate, first variable, second variable, or first coordinate, second coordinate. Okay, so the set of ordered pairs containing their corresponding values. Yeah. If the set of ordered pairs satisfy the function definition, then we say that the second variable is a function of the first. So back to the slide. So we'll see example. So here, you can see that here. Sometimes problems give you the not equation, but set of ordered pair like this. Okay, -2,5/3, and then -1,1, and 0,1/3. Okay, something like, for example. Okay, and then maybe the problem asking you to figure out whether or not this set is a function. Okay, sometimes. So anyway, so the function can be represented as an equation or the set of ordered pairs or graph. Okay, so now to next slide. All right, so example one. See, that example is similar to the example in the textbook. Okay, so example one. So decide whether A is a function of B and B is a function of A, or neither. So let's see. A is a universal product code for any item at Walmart, and B is its price. So we have to figure out whether or not A is determined by B, or B is determined by A, or neither. Okay. So, but just, using just common sense, definitely, the product price will be determined by what? Should be determined by the barcode, So B is a function of the function of A. Okay. So next example, A is the cost for mailing any first class letter, and B is its weight. Yeah, so the cost will be determined by what? Its weight, right? So A is the function of B. So now next one, A is the final exam score for any students in your class, and B is his or her semester grade. Yeah, so yeah, definitely final exam score will affect on your semester grade, but final exam score is not the only one effect on your semester grade, right? So not only final exam, midterm exam, and assignment and quizzes, a lot of factors. So B is not a function of A, or so A is not a function of B. So the answer is neither. Okay. So see, now you catch the concept of function, right? So now, oops. Now see mathematical definition of function. So we're gonna see two expressions, okay, of definition functions. But the second one is the important. That's the what you have to memorize. Okay. So first one, let's see the first definition. A function is a rule that assigns each element in one set to a unique element in a second set. So what's a function? Function rule assigned between two sets. Okay, actually domain range. Okay, and then the each numbers in the domain to a unique number in the range. Okay, you can say that. So what that means, you may see this kind of diagram, but okay, so back to this example right here. Okay, so okay, let's explain why this is function by using definition of function. By using the first definition of the function. Okay, so then the first one, see, I'm gonna collect all of the x coordinates. Okay, coordinate. Okay, so here -2, -1, and 0, 1, 2. Okay, pretty much, in this linear function, domain must be the set of all real number, right? Because x can be any real numbers. Okay, so simply normally we use a capital letter X for the domain. Okay, okay, and then now what? We're gonna collect all of the numbers. I mean second coordinates. Okay, so 5/3, and then 1 and 1/3, and then -1/3, and then 1. Okay, so normally we use a capital letter Y to denote the range. Okay, so what's the range? The set of all the second coordinate. Okay, so now then the based on definition of function, the first one, the function rule assign each element, the element nothing but just number, okay, in a domain, okay, number into the range one set to a unique element in a second set. The second set means the range, okay, to here, right? Okay. So 5/3. This is on the only the what y value corresponding to x value -2, right? So this is unique. That number is unique for the -2. Okay, so if there is another if there is another y value corresponding to -2, okay, so maybe there is other number right there in the y value, and then -2 correspond to that y value, then that's that's not going to be a function. Okay, that rule is not going to be a function. Okay, so but other I mean, one that possible is this: the what if other x value right here, that x value just correspond to 5/3? That should be okay. That should be okay. Okay, so as long as the for each x value has only correspond to only one unique y value, that then the what this relationship satisfy the function definition function. Keep in mind this. Okay, so this here, and then we normally use a letter Italy style letter f as symbol of function f, a symbol of function. Okay, so anyway, so the move to let's see, back to the slide. So now next one, function is a set of ordered pairs in which no two other pairs have the same first coordinate, different second coordinate. So why I just ask you to memorize this one, because you're gonna use this definition a lot. Okay, I mean, so let's figure out the meaning of this definition. A function is a set of ordered pairs in which no two ordered pairs have the same first coordinate but different second coordinate. So it means this. So okay, for example, let's say 1, 2, 3, 4, 5, 6. Let's say here 6. Just example, okay? Let's say the 6 x value, 6 correspond to not correspond. Okay, not this one. I'm sorry. Let's say -2 has another y value corresponding to -2. For example, 6. Sorry, right here 6. Okay, okay. Then expressing this as the set of ordered pair, we're gonna get this: -2, 5/3. Okay, and then -1, 1. Through so let me skip writing other pairs, and then we got this -2, 6. Okay, you see that here, negative. Look at the digital ordered pairs. We know that I told you, for each x value in the domain, it should have only one unique y value corresponding, right? But so this guy has two corresponding to two y value, right? 5/3 and then 6. So this is not a function. Expressing this one as it's a set of ordered pairs, what are you going to get? You see, -2, 5/3, -2, 6. These two guys have the same first but different second. So in order to be that that set is a function, this set should not have such a pairs ordered pair having the same first, different second. That's what the second definition says. Okay, so and then back to this example, equation of the circle. So now you can see that the reason why this circle is not a function, because you see that 0, 1 and 0, 0, -1. See that these two ordered pairs have the same first, different second. You should not have such a pairs ordered pair in order to that equation is a function. Okay, so keep in mind this. So here please keep in mind this. Here which no two ordered pairs. Okay, no two ordered pairs. Okay, do not be confused. Okay, so you just find out, find out two ordered pairs have the same first, different second. Oh, then this should be function. No, that should not be a function. Okay. Now, vertical line test. Okay, so let's look at this. Vertical line test. Yeah. So what's the vertical line test? I'm gonna explain in my scratch paper. So back to the equation circle. Okay. So x squared plus y squared is equal to 1. And then here x-axis. And then here's y-axis. Right. So this is 1 and -1 and -1, 1, right? Okay. So center point is 0, 0, and the radius is 1, right? So I'll just draw the vertical line. Okay. So yeah, you just draw the vertical line in any position. Okay, here or here or here. That doesn't matter. Okay. So just see how many intersection points. Okay. So these vertical line meet the graph. Circle twice, more than once, right? So because there is two intersection point. For each vertical line, we got two intersection point. It means that vertical line meet the graph more than once. Then that graph is not the graph of function. Okay, that's what vertical line test. So this circle does not pass the vertical line test. Okay, so let's see. So you see, a graph is the graph of a function if and only if there is no vertical line that crosses the graph more than once. That's what theorem says. Okay, so now we'll see the examples in textbook. Okay, so give me a second. All right, so 2.1, yeah, we saw example 1, right? Okay, so and then now define function. Yeah, so example 2. Determine which of the graphs shown in figure 2.2 are graph of functions. Yeah, now, yeah, see, it's not a big deal to, find out answer, right? So, okay, so you see that the figure A is not the graph of function. Why? Because see the vertical line meet the, the circle more than once, right? And then B, yeah, this is graph. This is graph of the function. Why? Because this graph passed the vertical line test, right? See, the vertical line meet the graph just once. And then C, yeah, we got two intersection point. Yeah, so C is that graph in C is not a function, graph of function. Okay. So now I'll move to the next example. Okay, so identify a function from a list or a table. Okay, so determine whether each relation is a function. So let's see. Yeah, A is what? A is a function, right? So because the set of order pair is given, right? So when the set of order pair is given, we apply the second definition of the function, okay? So then we try to find out the pairs of order pair having the same first, different, second. But see, all three order pairs have different first coordinate, right? 1, and then 2, right? And then 4. So all three order pair have different distinct first coordinate. So A must be a function. Okay. So now next one, the B. B is not a function. Why? Because just take a look at the first two order pairs, 9, -3, 9, 3. These two guys have the same first, different second. So B should not be a function. And then C. Yeah, so you see that here, see, table is given, but to better understand, let's try to express that table as the set of order pairs. Okay, then you're gonna get this 1, so let me see, back to the sketch papers. So example 3, okay, and then C. So then we got this 1, $9.40, and then quantity is 2, $9.40, right? Through the 5, 9.40. And then second row in the table, we got this 5, $8.75, right? Through the 10, 8, oops, 75. Okay. So from here to this, I know it's kind of weird, but so I just rewrite the table as the set of all the pairs. Now look at this, these two guys. These guys are same first but different second, right? So it means that C is not a function. Okay. So now, next one. Here, example 3, and then example 4. See, yeah, identify a function from an equation. So what if, equation is given and then ask you to determine whether each equation is a function, okay? I mean, in each equation, define y as a function of x. It means that y is determined by x, okay? So, next section, we're gonna study 10 popular, the graph of the 10 popular equations. Okay, so you should memorize them. Okay, the graph of the functions. Okay, otherwise you're gonna get big trouble in section 2.3. But so yeah, definitely we're gonna study the graph of these equations. But let me in section 2.2. But let me yes, I'll let you know the graph of these functions, okay, today. So give me a second. All right. So example 4. Why do we why do you need to know the graph of those equations? Because I want to apply the vertical line test to determine whether each equation is function of x. So example 4 there. So A, absolute y is equal to x. So just excuse me. So here, let's just plug in simple number into either x or y. Okay, either into x. Okay, let's say I'm gonna plug in 1 into x. Okay, 1, and let's find out y value corresponding to x value 1. Okay, then y should be 1, right? Because absolute value 1 is 1, right? But non-1, but there's a negative 1. When y equals -1, we're gonna get 1 as x value, right? 1, -1. So these two other pair must be on the graph of that equation, right? But anyway, you see that here 1, 1 and 1, -1. These two other pair have the same first, different second. So, that equation is not, in this equation, y is not a function of x, right? So the answer is no. This equation is not a function, okay? But what does graph of this guy look like? The, see? Okay, so should be graph must be like this. Here, x-axis, y-axis, okay? Okay, so when x is 1, so x value, x coordinate 1 corresponding to 2 y coordinate, -1 and 1. But not only 1, but also, every single, the x value, they have 2 distinct y value corresponding, okay? But here's a question. Then what about, x? Can x be the what, negative number? X can be negative? No. Because see the absolute value y equals x. It means that what? Absolute value y always return positive number, right? So x must be a positive number. Okay? So that's why graph does like this. So from here we can find our domain range. So let's find domain range. Yeah, so yeah, that one cover yeah, I'm gonna cover finding domain range and graph of the equation 2.2, but now let's find out domain range too. So what's the domain? Domain is what? The set of all of x coordinates. So that domain must be on the x-axis, okay? So domain is part of the x-axis. In other words, domain is what? The interval lies on the x-axis, okay? So see, x can be 0, right? And then 1. So x can be any positive real number, including 0, right? Including 0. So domain is what? Domain is 0 to infinity. Okay. Then what about range? Range, what's the range? Range is the set of all the y coordinate, right? So let me use other highlight. So then what? Domain y can be any real number, right? As you can see that in the graph, right? X, y can be any positive number or any negative real number, right? Okay. So range is gonna be what? Negative infinity to infinity, which is the set of real number. So range, negative infinity to infinity. Okay. Okay, like this. So now, anyway, this is not a function. Okay. So in here, y is not uh, a function of x. Okay, that's answer. The b, y equals x squared minus 3x plus 2. So the when y equals 0, plug in 0 into y, then we're gonna get quadratic equation, right? So the instead of 0, we got y in the left hand side. So then this is called the quadratic equation. Okay, so the quadratic equation, the graph of quadratic equation should be either like this or like this. Okay, oops. Okay, it's called parabola. It's parabola opens up. Okay. Okay, it's parabola opens up, parabola opens down. Okay. So now you can see that what these two either parabola pass the vertical line test, right? Okay. It's because you see the vertical line pass the graph only just once, right? For either cases. Okay. So in this case, in this problem, y is what? Y is a function of x. The answer is y. Y is a function of x. Okay. And then C, x squared plus y squared equals 1. Yeah, let me skip it. We saw that, right? We figured out the answer for this. What is the answer? No. Every single cycle is not a function, okay, of x. D, 3x minus 4y equals a. This is a linear equation, right? So we know the graph of linear equation, a straight line. Every single straight line is a function, graph of function. Why? Because, you know, for example, in this case, graph must be like this, okay? But for any, you know, for any slope of the line, the straight line must meet the vertical line at once. Okay, for any line, right? For any straight line, just meet the vertical line just at once. Okay, so D is in here, that equation, y is a function of x. Okay, so D is a function, C is not a function, B is function, A is not a function. Okay, keep in mind this. So now, now example 4, and then domain range. So let's see. Move to next slide. Yeah. So yeah, we already know that what's domain and the range, right? Domain of a relation. So here, look at the definition of domain range. Domain of a relation. They don't say domain of function. So for given set of ordered pair, even though the set is not a function, we can find out domain and range. Okay. Keep in mind this. So it's the example. 19,2.4 and then 19,33.6. You see that here? These two guys here, those two ordered pair have the same first, different second. So this set is not a function. It's just a relation, okay? Between between the set of first coordinate and the second coordinate, which means that we can find a domain range. Okay. So this domain is what? 19, 27. You don't have to repeat the same number, okay? 19, 27, 22, 36. The set of 19, 27, 22, 36, that's going to be domain. The range is going to be what? The set of 2.4, 3.0, 3.6, and then we got 2.4 already, right? So skip it, and then 3.8. So that's going to be range, okay? So now move to the next slide. A function defined by a set of ordered pairs can be named with a letter. Yeah, so before studying function notation, let's go back to textbook to see examples of domain range, okay? And then I'm going to explain about function notation. Let's see. Yep. All right, so example 5. State the domain and range of each relation and whether relation is a function. Okay, and then variables represent real numbers only. Okay, so yeah, so whole throughout the chapter 2, we only deal with the set of real number. Okay, we don't deal with complex number. Keep in mind this. So example 5. Okay, so A, B, C. Okay, A is the set of ordered pair given, and B equation and C equation. So in B and C equations are given, right? So now here, example 5. Okay, so A, -1 and 1. Okay, and then 3,9, and then 3, -9. Okay. Oops. Oop. All right, so then domain gonna be what? It's really easy, right? So domain is just collect all of the first coordinate, right? -1, 3. That's it. That's the domain. Okay. The range is gonna be what? 1. Okay. And then 9 and -9. Okay. Let's see. Then B, y is equals square root of 2x minus 1, right? Let's see. 2x minus 1. Yeah. Yeah, you're gonna see this kind of problems. I mean, you're gonna see problem asking you to find the domain range for this kind of function involving square root. Then how can I find out? All right, for the domain. Okay. Let's see. All right, find the domain. All right, so just think about this: 2x minus 1. This is the 2x. The quantity of 2x minus 1 must be greater than or equal to 0. Why? Because 2x minus 1 is under the square root, right? If a 2x minus 1 is turns out to be negative number, then we're gonna get complex number for y value. That doesn't make sense because I told you we deal with the real number only in this section, in this chapter too. Okay, so 2x minus 1 must be greater than or equal to 0. Okay. Okay. So then, yeah, we know how to solve that linear inequality, right? So x must be what? Greater than or equals 1/2, right? Okay. It means that what? 1/2 to infinity, right? This is the domain. Okay. So the answer is what? Domain is closing number 1/2 to infinity. Okay. Then how can I find domain range? Uh, that's easier than finding domain. Why? Because the square root, okay, the square root term must be greater than or equal to 0. Okay, so but think about this. Can you find out square root of something? Square root of something is less than 0. Square root of something is less than 0. Can you find out the example of satisfying this condition? No. The square root of something is always greater than or equal to 0. Okay, it means that square root of 2x minus 1 must be greater than or equal to 0. It means that y must be greater than or equal to 0. Because square root of 2x minus 1 is greater than or equal to 0. Okay, so the range is going to be what? 0 to infinity. Okay, all right. So now the C, x is equal to absolute y. Okay. Now we sell the graph of this array. So we already figured out domain range right here. Domain is 0 to infinity, range negative to infinity, right? Okay, so please look at this one. So skip the C. Okay, so that's the problem example 5. And now next example. All right, so function notation. Yeah, so I'm going to explain function notation. Okay, so a second, back to here. Okay, so let me explain function notation and then just let me stop. Okay, so now function notation. Okay, we go to the slide. Yeah, yeah. So function defined by a set of ordered pairs can be named with a letter. So I gave you one example, right? So letter F. Okay. So, but back to example. Back to sketch paper. So function notation. That's the objective number 5, right? So function notation. Okay. So we use the letter F. Okay. F is equal to. So if the set order pairs is given, and then it turns out that the set is a function, then we can express that set using the letter F. Okay, 2,5 and 3,8. Okay, just an example. Okay, also you can use the letter G or letter H. Okay, it doesn't matter, but normally we use the letter F. And then what does that mean? So the F of 2. Okay, once the the f is defined as the set of order pairs like this, 2, 5, 3, 8, then we could express the second coordinate in the first order pair using the letter f of 2. That is 5. Okay, that does not mean f times 2. Okay, we read this one as f of 2 is 5, or the value of f at 2 is 5. So now we can figure out the meaning of f of 2. The meaning f of 2 is the second coordinate corresponding to x coordinate 2 in this function, in this set of ordered pairs. Okay. All right. So yeah, I saw a lot of students got confused about the that's function notation. Whenever, so we're gonna see, you're gonna use f of 2, that expression, so many times, okay, from now on. So you need to clearly understand what does that mean, f of 2. F of 2 is nothing but just y value corresponding to x value 2. Okay. So now then, what about the f of 8? f f of 8 is what? 3. F of 3, sorry, f of 3 equals 8. Okay. So f of 3 means that what? Y value corresponding to x value 3, which is 8. So f of something actually represent what? Y coordinate. Okay. So it's the example, one more example. So yeah, think about this. Y is equal to another example. Okay. So example. So y is equal to 2x plus 3. Okay. So we know this is a linear equation. I told you every single straight line is what? Pass the vertical line test. So every single linear equation must be, with two variables, must be a function of x. Okay. So now y is a function of x. Then instead of using y, I'm going to replace this one with f of x, 2x plus 3. Okay. All right. So now I'm not going to use a letter y anymore. And then I'm going to use f of x, function notation. Okay. So because here x represent first coordinate, right? Excuse me. So this x will represent the first coordinate. Okay. Okay. And the y, that represent the second coordinate, right? Or a y coordinate, either one just fine. Okay. So now, what did I say about the f of x? That symbol of what function? Yeah, that's definitely this f of x. F is a function notation, and the f of x means that what? Second coordinate corresponding to x coordinate. First coordinate x. Okay. So f of x equals 2x plus 3 is nothing but y equals 2x plus 3. Okay. Now here, and then we can say that we can use letters other than f. Okay. For example, g of x, this is equal to x plus 3. Okay. So g of x equals 2x plus 3. This is nothing but f of x equals 2x plus 3. So these two functions are identical. Okay. Also h of x, 2x plus 3. So three functions are identical because three functions, their definitions, 2x plus 3, identical, right? So, and then what about this? G z equals 2z plus 3. Then can you say that that function is identical to f of x? F of x? Yes. Okay. Because look at the rule. Definition of function. 2z plus 3, right? It means that the 2 times the first coordinate plus 3. In here, when you look at the rule of that function f, 2 times the first coordinate plus 3. So these two guys have the same function rule, right? So these two functions must be identical. So now here we can figure out that the letter x just, there's nothing but the first coordinate. So it's important. So the x is called the dummy variable. X and z are dummy variable. Okay. Because x doesn't mean, x just means nothing but just what? the first coordinate. So we can use any letter other than x. Okay, z or w or any other letter. That should be fine as long as the function rule is same. Then two functions must be identical. Okay, so now in the next slide, let's see. All right, so okay, function defined by an equation can also be named with a letter. I told you, right? We can use g of x, read it as g of x as a symbol for the second coordinate when the first coordinate is x. Yeah, the notation is called the function notation. Yep, and the x in this notation is called a dummy variable because the letter used is unimportant. Okay, and now see example in textbook. Yeah. Okay, example 6. Okay, so let H is equals set of ordered pairs 1, 4, 6, 0, 7, 9, and the f of x defined by square root of x minus 3, and then find each of the following. Yep. All right, so now example 6. 6. Okay, H, the set of pair 1, 4, 6, 0, and 7, 9. Okay, and then f of x, square root x minus 3. Okay, and the A, H of 7. Okay, then B, W, 0, C, F of 7, D. All right, so, okay, so see, H of 7. I told you, H of 7 means what? Y value when X value is 7, right? So here, we'll find all the pair whose first coordinate is 7, okay? Here, right here. You see that? Okay. Okay. So then what? The 9, that's the H of 7, right? This is 9. Okay. So now you see H of W, the B, we want to find a W if H of W equals 0. So 0 means what? Y value. Okay. And then that means W is X coordinate corresponding to 0, right? So we want to find out W where W is the first coordinate and then Y coordinate is 0. Okay. So in H, you see that? Look at the second order pair in H. See? In this second coordinate, the its y coordinate is 0, right? So W must be what? 6. Okay. And the f of 7 is what? Here, f of 7, you have to completely replace x in the function rule with 7. Okay. So I'm gonna replace every single x on the right hand side of function definition with 7. Okay. So f of 7 must be square root of 7 minus 3. Okay. And now, which is what? Square root 4, which is 2. Okay. And then you see f of x equals 5. Well, if you want to find out x where f of x equals 5, then what? Because that means we need to find the x where square root of x minus 3 returns 5, right? So we have to solve what? Square root of x minus 3 equals 5, right? Okay. Or simply just saying that just plug in square root of x minus 3 into f of x. Or okay. So now we can solve it, right? Because we just take a square. Taking square left hand side, right hand side, and both sides to get rid of square root. Then we got this x minus 3 equals 25, and then x is what? 28. See? Okay. So when x equals 28, we're gonna get 5 as y value. Okay. So let me see. 6. Okay. Now, yeah, from the example 7, okay, So I'm gonna cover from the example same next time. Okay. So let's take a roll, and then let me stop here. Okay. Let's see. Okay, screen.